Parallel perpendicular lines in R2. They've given us two lines in Cartesian form. It tells us to prove that these two lines are parallel and non-coincident. Now, remember, these lines we're talking about right here give us information about their normals. So if they're parallel, that means the normals to both of these lines must also be parallel. So let's kind of try to draw that out. Here's our plane. If we have two parallel lines, okay, say those are parallel, that also means that their normals, so from the origin to this one, and from the origin to this one, must also be parallel. Okay? They might be shifted a little. Well, let's find out. Now, this isn't exactly what the lines look like. This is just an idea of them. Okay? We could have also had two other parallel lines, and we could have had something else coming from the normal to it. So, first of all, what I'm going to do is I'm going to use this information to find the normal of each line. If you guys recall, the normal vector is also our AB. Those are the components of it. And the A and B in our Cartesian form are AX plus BY plus C equals 0. So our A value is essentially the coefficient in front of X, and our B value is coefficient in front of Y. So the normals for each line, line 1 we'll call it, the normal for that line is from the origin to point 3 and negative 4. And the normal for our line 2 is 6 and negative 8. Okay. Now, what we want to find out is one a scalar multiple of the other? Okay. And if you look quickly, we could factor the number 2 out of the second normal, and we would get 3 and negative 4, which means the normals, or the directional vectors for both of the normals, are parallel to each other. So we do know that. They are both parallel to each other. What we then have to do is prove that they're non-coincident. In other words, they're not right on top of each other, these two lines. We have to prove that. Okay? So, in order to prove this, we got to look at the two lines originally. In order to be coincident lines, or essentially the same lines, one has to be a scalar multiple of the other. So if we have line 1, 3x minus 4y minus 6 is equal to 0, is it, and this is what we're asking, is it equal to some scalar, we'll call it k, of 6x minus 8y plus 12 equals 0? Can I just multiply one of the numbers by, or one of the entire equations by a number to get the other? Well, to go from 3 to 6, we would multiply by 2. Can I continue to do that? If I multiply negative 4 by 2, I will get negative 8. And if I multiply negative 6 by 2, I don't get positive 12, I get negative 12. Okay? So in other words, what this is saying is these lines are parallel to each other, but they're not the same line. Right? So they are two separate lines that are just parallel. Because we can represent the same line with different equations, we have to check to make sure we're not actually talking about the same line twice. And that's what this question was asking. B is a similar type question. Let's scroll down to it. Okay. B wants to know for these two lines, and one of them is kx plus 4y minus 4 equals 0. And the other line is, or other vector I should say, 3x minus 2y minus 3 equals 0. For what value of k are these perpendicular, is what it's asking. Okay. So what we could do is we can, again, find the normals to both of these. Because it's in Cartesian form, we're going to relate it back to its normal. So the normal of the first line will be of a k value for our x and a value of 4 for our y. And the normal of line 2, we'll call this normal 2, is equal to 3 and negative 2. Okay, and this is normal 1. Well, if they're going to be perpendicular to each other, we know the normals will be perpendicular to each other also, which means that the dot product of normal 1 times normal 2 is going to be equal to 0. Okay. So what we're going to do is we're going to put these values in. Well, normal 1 will be k and 4 multiplied by 3 and negative 2 is equal to 0. That means 3k plus, minus, I should say, minus 8 is equal to 0. Okay, and all we did there is multiply k by 3, and then we added it to 4 by negative 2, which then gives us 3k equals 8, k equals 8 over 3. So, relating that back to the beginning, what that says is this equation number 1, we'll do it in blue, with a value of 8 over 3x plus 4y minus 4 equals 0, would then be perpendicular to this line 2. 3x minus 2y minus 3 equals 0. So we just were able to prove it going through this process and find the value of it.